In this session, we are going to be attempting RI 2021 JC1 promotion exam paper. I think it is quite a pretty manageable paper. Let's give it a try. Question number 1, we have a system of linear equation question where curve C is given to us with an equation y is equal to ax plus b over cx minus 2. We are given that curve C passes through the points with coordinates 1, 5 and negative 8, 0, 5. So at the point 1, 5, x is equal to 1 and y is equal to 5. So with this equation that is given, 5 is going to be equal to a times of 1 plus b divided by c times of 1 minus 2. Cross multiplying this will give us a 5c minus 10. This is equal to a plus b. Bring this over to the right hand side. We have a plus b minus 5c. This is going to be equal to minus 10. This will form for us our first equation. And at the point that is given to us as minus 8 and 0.5, with this point, which satisfies this equation here, y is going to be equal to 0.5 and x is going to be equal to negative 8. So this plus b divided by c times of negative 8 minus 2. Cross multiplying this, we will get a minus 4c minus 1. This is equal to negative 8a plus b. Bring this over to the right hand side. We have a, okay, let's bring everything over to the left hand side instead. So bring this to the left hand side. We have a positive a minus b minus 4c. This bring over to the right hand side is going to be equal to positive 1. So this is equation number 2. And the question tells us that this curve C is going to be undergoing a transformation. The transformation is a translation of 1 unit in a positive x direction. So we have learned before, when a curve is translated by 1 unit in the positive x direction, all the x is going to be replaced by x minus 1. So with the transformation, let me write down the equation of the new curve. The new curve is, okay, I'm spelling curve wrongly. Let me just rewrite this, okay. So the new curve, C-U-R-V-E, the new curve will be y is equal to a times of, I'm going to be replacing all the x that I can see there by x minus 1. So here will be x minus 1 plus b divided by c times of x minus 1 then minus 2. This will make sure that this new curve is a translated version of this by 1 unit in the positive x direction. And for this new curve, it is going to be passing through a new coordinate, a coordinate that is 0, negative 0.2. So for this new curve, at the point 0, negative 0.2. So y is going to be equal to negative 0.2. This is going to be equal to a times of x is going to be equal to 0. So this will just be minus 1 b divided by c times of minus 1 minus 2. Cross multiplying this, we will have a 0.2 c plus 0.4. This is going to be minus a plus b. Bring this over to the left hand side to combine with this. We will have a minus b plus 0.2 c is equal to, bring this over to the right hand side, negative 0.4. This gives us our third equation. So equation number 1, 2, 3, 3 equations with 3 unknowns a, b, c. We are going to just press it into our graphing calculator. So from our graphing calculator, we will be getting a to be equal to 2, b is going to be equal to 3, and c is going to be equal to also 3. Let's take a look at the next one. The next one is a differentiation question. And for this next question here, question number 2, we are given y cubed is equal to 4 minus xy squared divided by 2. We are supposed to find dy dx and showing that it is equal to that expression that is given to us. So we're going to be differentiating this, but I think I'm going to multiply this throughout by 2 first, so that I don't have this divided by 2 denominators. Not something that is very difficult, but I think we can settle with something that is like this. So 8 minus xy squared. So let's differentiate this with respect to x. On the left-hand side, it is going to be 2 times of 3y squared dy dx is equal to, differentiating it is equal to 0. Here, I'm going to apply the product rule. Negative x, I'm going to let it be. Differentiating y squared is going to be 2y dy dx. Then differentiating negative x gives me a negative 1 multiplied by y squared. I'm going to rearrange this so that dy dx is going to be the subject. So I'm going to bring this over to the left-hand side. So this will be getting a 6y squared dy dx. Then this, bring it over to the left-hand side, it is going to be plus 2xy dy dx. This is going to be equal to negative y squared. We're going to divide throughout by y, but let's do a quick check to just make sure that we are able to divide it by y, just in case, okay? Just in case y is equal to 0. So let me do a check. So if y is equal to 0, let's verify against this. If y is equal to 0, then the left-hand side is going to be y to the power of 3, which is going to be 0 to the power of 3. This is going to be equal to 0. But on the right-hand side, when y is equal to 0, we'll be getting a 4 minus xy squared over 2, which is going to be equal to 4 minus 0. It is equal to 4. This is not equal to the left-hand side, so it is impossible for y to be equal to 0. We are safe. We can then divide throughout by y for this particular equation here, which will give us a 6y. Then dy dx is equal to, so it's plus 2x dy dx. This is going to be equal to negative y, and we are able to do so because we have just checked and we know that y is not equal to 0. So making dy dx the subject, we have dy dx, then 6y plus 2x is equal to negative y, which means that dy dx here is equal to negative y over 6y plus 2x. This is going to be part 1. And in part 2, let me just do it here. So for part 2, we are supposed to find the equation of the normal to the curve C at the point P. And at point P, y is equal to 1. So at point P, y is equal to 1. If y is equal to 1, we will also be able to find the x coordinate at point P. So I'm going to make use of this or this. Let's just go for this. So at point P, y is equal to 1, so we have a 1 to the power 3 is equal to 4 minus x multiplied by 1 square over 2. Based on this equation over here, this will help me to solve for the value of x. X here is going to be equal to 6. So at the point P, we will be looking at a point with the coordinates as 6, 1. And we are supposed to find the equation of the normal. We need one more thing, which is the equation, the gradient of the tangent at point P. So the gradient of the tangent, dy dx, making use of this, is minus y. Y is 1. 1 over 6 times of y plus 2 times of 6x. So this is equal to negative 1 over 18. So we have this point P. It is maybe, let's see. So dy dx is that. So let's say we have this, and we have a tangent, and this point P is 6, 1. The gradient of this tangent is minus 1 over 18. And the question is asking us about the normal, which is 90 degrees to this, which means that the gradient of the normal is going to be negative 1 over 18. So the gradient of the normal is going to be equal to 18. So this will help us to find the equation of the normal, which is going to be y minus the y coordinate is equal to the gradient of the normal, which is 18, x minus the x coordinate, which is 6. I can definitely rearrange this into the form of y is equal to mx plus c, and that will be 18x minus 107. Okay, this is question number 2. Let's move on to question number 3. Here, it is a vectors question, I guess. So we have points A, B, C with position vectors A, B, C respectively. So let me write it down. So we have a OA position vector A. OB, the position vector B, and OC is given to us as C. We want to show that the area of triangle ABC. Let me just do a quick sketch of this part A over here. So we have a triangle. Let's say it is this triangle. For example, here we have A, this is B, this is C, ABC. We want to show that the area of this triangle ABC is equal to that expression over here. So I'm going to make use of what we have learnt in vectors. I'm going to use these two sides. That is two sides that bind the, two sides of the triangle. So I'm going to use these two sides and I'm going to try to find the area by doing a half of modulus of AB cross AC. Or you can use any of the other two sides. Okay, you can use AB, you can use BC as the two sides. It doesn't really matter. Any of the two sides will give you the correct answer. So if I'm using AB, that means this is going to be equal to OB minus away OA. And AC, this is going to be OC minus away OA. So we have this. So this is going to be equal to half of modulus of AB, which is B minus A, cross AC, which is going to be C minus A. So we have this. Let's expand this. Okay, let's manipulate this. So it will be half of B cross C. So here, then B cross A. So negative of B cross A. Then this and this will be negative of A cross C. This will be plus A cross A. But A cross A is equal to 0 because the angle that is between A and another vector, which is also A, is 0 degrees. So when we have A cross A, this is going to be modulus of A, sine of the angle that is between them, which is 0 degrees, and sine 0 degrees is 0. So because this is equal to 0, that is why A cross A is going to be a 0 vector. That is what we will be expecting here, a 0 vector. It will just disappear. So what we're going to be having here is going to be a half of modulus of, let's see what we are supposed to be proving there. Okay, so we're going to manipulate this a bit to make it look like the one that we are supposed to be showing. It started off as half of modulus of A cross B. Do we have an A cross B here? Yes, we have. It is from here. Minus B cross A is the same as positive A cross B. So this will become A cross B. The second term that we are supposed to prove, we already have it here. So it's just going to be plus B cross C. And the third term is positive C cross A. So negative A cross C is positive C cross A. So positive C cross A. And since this is equal to 0, this is already showing what we are supposed to show. Hence, the question says, show that the shortest possible distance from B to the length AC is equal to that expression. The shortest possible distance from B to the length AC. So we are looking at this. What is this if I were to look at it from the perspective of area of triangle? This length here, this shortest possible distance from B to AC, is also the height of the triangle. So area is half times base. Base is AC modulus, right? This is the length, times height, which is what I've just drawn here. This is the height. So this is equal to half of modulus of A cross B plus B cross C plus C cross A. And what is AC? AC is C vector C minus vector A, C minus A. So we have half that is going to be cancelled, which means that the height, which is also going to be the shortest possible distance from B to AC. Let me just write it down. Height, which is also going to be the shortest distance from B to AC. Height is going to be equal to modulus of A cross B plus B cross C plus C cross A divided by modulus of AC. And this is equal to modulus of A cross B plus B cross C plus C cross A divided by this is going to be modulus of C minus A. Okay. This one is also done. Part A. Let's look at part B. So for part B, we are given that A, B are non-zero vectors such that the modulus of A minus B, modulus of A minus B, this is going to be equal to the modulus of A plus B. Find the value of A dot B. So we want to bring in the dot product to something that has modulus. There's a result that we have learned in vectors. The result is one that is for a vector, let's say vector A, dot itself. Vector A dot vector A. If we were to go through the definition for dot product, this is equal to modulus of A. Modulus of A, cosine of the angle between A and A is 0 degrees. And what is cosine 0 degrees? This is 1. So this is equal to modulus of A squared. We're going to go from here to here. This is the result that we have already known. We can actually apply it directly to this. But before we can apply it, we need a modulus square. So I'm going to square both sides for this. This is going to be modulus of A minus B square is equal to modulus of A plus B square, which can then help me to change this to, according to this result, A minus B dot itself. So A minus B dot A minus B, this is equal to A plus B dot itself, dot A plus B. Let's manipulate this further. So we have A dot A dot A, then minus away A dot B, this will be minus B dot A, then plus B dot B is equal to, this is A dot A, this plus A dot B, this will be plus B dot A, and this is going to be plus B dot B. So B dot B will disappear, A dot A will be cancelled away also. As for what that we have on the left hand side, B dot A is the same as A dot B. So we have a minus A dot B minus A dot B. It gives me a minus 2 A dot B. For the right hand side, A dot B is equal to B dot A. So this is the same as A dot B. A dot B plus A dot B. On the right hand side, we have a 2 times of A dot B. Bring this over to the right hand side, we have a 4 times of A dot B. This is equal to 0. So A dot B over here is equal to 0. This is part B. Let's take a look at the next one. Question number 4. Okay, in question number 4, part 1, we are supposed to find UN in terms of N. So for part 1 of this question number 4, UN is given to us as this summation from R is equal to 1 to N of 2R plus N plus 1. So 2R plus N plus 1. Okay, we are supposed to evaluate this summation. I'm going to break it up into 2 parts. One will be the one that has R. 2, I'm going to bring it off the summation notation. So it's going to be 2 times of R is equal to 1 to N of R. The other part is going to be N plus 1. Why do you want to group N plus 1 together? Because N plus 1 is a constant. Okay, let's not be careless in terms of us accidentally seeing this N here as a variable. The variable is R, not N. N is here, and whatever that is here is a constant. So N plus 1 by itself is a constant. So we are basically just trying to sum a constant N plus 1. So as for this summation of R from 1 to N, we can either apply the AP formula, or we do have a formula about this in our Achevas TV outline. So I can make use of that also. It is going to be N, then after that here is N plus 1 divided by 2. That is meant for this, plus this. This is a constant. What is the sum of a constant? It is going to be the constant multiplied by the number of terms. So the constant is N plus 1 multiplied by the number of terms is N of terms, but it is N minus 1 plus 1. Okay, if you want to use formula, N minus 1 plus 1, but we know it is a N number of terms. So 2 and 2 can be cancelled. We have a N times of N plus 1. plus this is also going to be n times of n plus 1, which means that this is equal to 2 times of n of n plus 1. Next, part 2, we are supposed to show that Vn is equal to 1 over n minus 1 over n plus 1. And what is Vn? According to the question, Vn is 2 over un. Let me make use of this result. Okay, we are going to be making use of un. So we know un is equal to 2n n plus 1. Let me erase this. So for part 2, we are supposed to show that Vn is that, right? And the question tells us that Vn is equal to 2 over un, which means that it is going to be 2 over 2n n plus 1. 2 can be cancelled. It is 1 over n plus 1. And we are going to carry out a partial fraction process. So we are going to let this 1 over n plus 1 be a over n plus b over n plus 1. And I'm going to use the cover-up rule. By making use of the cover-up rule, we know that a is going to be equal to, I'm going to be covering up n, and I'll let the rest of the n be the n that caused the denominator here to be equal to 0, which is 0. So covering up this, it is going to be 1 over, this n is going to be replaced by 0, a is going to be equal to 1. As for b, again using the cover-up rule, we are going to be covering up n plus 1, replacing n by minus 1, which caused the denominator to be equal to 0. So b is going to be 1 over minus 1. It is equal to minus 1. So this is going to be 1 over n minus 1 over n plus 1. Therefore, we can see that Vn is going to be equal to a, which is 1 over n. b is minus 1 over n plus 1. This is what the question wants us to show. And part 3, we are supposed to describe the behavior of the sequence V1, V2, V3, V4, V5, V6, all the way until, I guess, infinity. So what will the sequence become? As n goes to infinity, Vn, which is equal to this, will go to 0. This will go to 0. So my answer for part 3 will be the sequence will converge to 0 because V infinity is 0. So you'll slowly become smaller and smaller and smaller, and ultimately it's going to become 0. And next, part 4, let me write it down here. Part 4, we are supposed to find Sn for the first n terms of the sequence V1, V2, V3, and so on. So Sn, according to what the question has described to us, Sn is the summation from n is equal to 1 all the way until n of Vn. And Vn is equal to this. So this is going to be summation from n is equal to 1 all the way until n of this will be 1 over n minus 1 over n plus 1. Expanding this and presenting it in the method of difference structure, it is going to be equal to 1 over 1 minus away 1 over 2. This is when n is equal to 1. When n is equal to 2, we have a 1 over 2 minus 1 over 3. When n is equal to 3, it is going to be 1 over 3 minus 1 over 4. So we can see the pattern of cancellation to be going this way. We are going to try to verify this pattern of cancellation by writing down the last 2 terms. That is when n is equal to n minus 1. So we have a 1 over n minus 1 minus 1 over n. And the last row here will be when n is equal to n. So that will be 1 over n minus away 1 over n plus 1. This can be cancelled, and we can imagine that all the rest here are going to be all cancelled, which means that this is going to be equal to 1 minus away 1 over n plus 1. This is part 4, and in part 5, give a reason why this series Sn is going to be converging. So why is it converging? Because when n tends to infinity, 1 over n plus 1 will tend to 0. And this is the only term that affects Sn. So if this converges, Sn will converge also. Therefore, Sn converges. And write down the sum to infinity. So we are writing down sum to infinity, which is going to be 1 minus 0. So the sum to infinity is equal to 1. Next, question number 5. Let's see what it is. It is a Maclaurin's question. Part 1. By using standard results from the list of formula MM26, we are supposed to expand this. Let me write it down. We have this cosine of 3x over 4 minus x. So if I were to make use of what we have in our MF26, let me just take a look at the MF26. So in our MF26, under the part on Maclaurin's, we have this. So the two results that we're going to be making use of will be, one is this for the cosine 3x in the numerator. The other one is going to be this, where we try to bring the denominator up, and it is going to be to the power of -1. So it is going to be here cosine 3x and then 4 minus x to the power of -1. So for cosine 3x, okay, let me just do a manipulation first. How about taking out 4? So cosine 3x, I'm going to let it be. For 4, I'm going to take it out so that it will become 4 to the power of -1. Then this will be 1 minus 1/4 x to the power of -1. At least this is this makes it even closer to the expression that is like this, 1 plus x, where x can be replaced by -1 over 4x. So we can make use of the result again. So cosine 3x, making use of the result for cosine x, which is here, it is going to be 4 to the power of -1 is going to be 1/4. Okay, cosine 3x, if I were to make use of the result that is there, it is going to be 1 minus x squared over 2 factorial, where x is going to be replaced by 3x. So it is going to be 3x squared over 2 factorial. The next one is going to be 3x to the power of, according to the MF26, right? The next one is going to be x to the power of 4. But x to the power of 4 will cause 3x to the power of 4 to give me x to the power of 4. And the question is actually asking us to expand all the way up to the term x to the power of 3. Okay, the question is this. We're supposed to be expanding only up to x to the power of 3. So I'm going to ignore the next one. So this is it for cosine 3x. As for this, again, by making use of what we have in our MF26, we have this. So it's going to be 1 plus n is this -1. So -1, x is going to be replaced by -1/4 x. Then the next term will be -1 minus 2 divided by 2 factorial, -1 over 4x squared. We are going to continue because we are going to go all the way up to the x to the power of 3 terms. So one more term, -1 minus 2 minus 3 divided by 3 factorial, -1 over 4x to the power of 3. And all the rest of the terms, I'm going to just leave it alone, not showing it anymore, since it's going to be x to the power of 4. Let's just simplify these two expressions here, okay? So 1/4, this is going to be equal to 1 minus 9 over 2x squared. As for this, simplifying it, it is going to be 1 plus 1/4 x plus 1 over 16x squared plus 1 over 64x to the power of 3. Let's expand this further. We should be getting the result very soon. So this is going to be equal to 1/4. This 1 multiplied by this. So 1 times 1 is going to be 1. This times this. 1/4 x, 1 over 16x squared, 1 over 64x to the power of 3. And this times this, minus 9 over 2x squared. We still want this. So this will be minus 9 over 8x to the power of 3. This I think we can ignore because it's going to be giving us something that is more than x to the power of 3. So the rest, I'm going to just leave it within this plus dot dot. And evaluating this some more, this is going to be 1 plus 1 over 4x minus 71 over 16x squared. Then we will have a 71 over 64x to the power of 3. I think this is fine. We can definitely multiply this in. I don't think it is super necessary, but if I were to multiply in, we have a 1/4 plus 1 over 16x minus 71 over 64x to the power of 2, then minus 71 over 256x to the power of 3, and so on. So this is the expanded form, and the question wants us to do in part 2. Oops, this is part 1. So in part 2, the question says that it is given to us that the third and the fourth term found in part 1, which is this, the third and the fourth term. So we have this, the third term, 1, 2, 3, third term, and the fourth term. The third and the fourth term found in part 1 are equal to the third and fourth term in the series expansion for this, a plus bx to the power of 5 in ascending powers of x. So we are supposed to find the values of a and b. So a plus bx to the power of 5. Again, if I were to refer to what we have in our ML26, in our formula sheet, we can't use this anymore because there's another expansion that is more valid for the situation now, which is this expansion, the binomial expansion, because this expansion here is valid for the situation when n is a positive integer. Let me reduce this a little bit. So when n is a positive integer, and now we have this power as a positive integer, so we need to make use of this. Let's expand this. We will expand this up to the fourth term, since the question is only requiring us to compare the third and the fourth term. So the first term is going to be equal to a to the power of 5. Then after that, 5 choose 1. A to the power of 4, then bx. Then after that, it is going to be 5 choose 2, the third term, a to the power of 3, bx square. And the fourth term will be 5 choose 3, a to the power of 2, bx to the power of 3, and so on. So this will be equal to a to the power of 5 plus 5, a to the power of 4, bx. This is 10. Then we have here a to the power of 3, b square x square. Then this is also going to be equal to 10, a to the power of 2, b to the power of 3a cubed. So the question says that the third term is going to be equal to the third term. The fourth term is equal to the fourth term. So let's match this. So we have a third term. It is this. So we have a 10, a to the power of 3b square. The coefficients will be the same. So this is going to be equal to negative 71 over 64. This will form for me my first equation. Then after that, let's match the fourth term, which is going to be 10, a to the power of 2, b to the power of 3. This is negative 71 over 256. This is the second equation. So I have two equations with two unknowns, a and b. I'm going to try to attempt to solve for a and b by, let's take a look at it, by taking equation number 1, dividing it by equation number 2. That will give us a 10a to the power of 3b squared divided by 10a to the power of 2b to the power of 3. This will be this divided by this, negative 71 over 64 divided by negative 71 over 256. This will give us, 10 can be cancelled. This will give us a over b is equal to 4. This tells us that a is equal to 4b. I'm going to call this equation number 3, which I'm going to substitute it back into either equation number 1 or equation number 2. Let's just sub it back into equation number 1. So for equation number 3, let's put it back into equation number 1. So we have a 10a. A is equal to 4b. So 10 times of 4b to the power of 3 times b squared. This is negative 71 over 64. This gives us a b to the power of 5 is equal to negative 71 over, this is a large number, negative 71 over 40960. Okay, we can find b. B is going to be the fifth root of this. Fifth root of negative 71 over 40960. If I were to press it into my calculator to 3 significant figures, it is negative 0.280, which we can substitute it back into here to find a. So a is going to be equal to 4b. It's going to be 4 times of the fifth root of negative 71 over 40960, which if I were to press it in my calculator, it is negative 1.12. Okay, this is question number 5. We can proceed. So from question number 5, we are going to move on to the next one, which is question number 6. This question number 6 is a graph question together with an inequality. Okay. So in question number 6, part 1, on the same axis, we are supposed to be sketching the two graphs and stating the coordinates of any points of intersection with the axis, and we are supposed to also state all the turning points and the equation of the asymptotes. Let's sketch the graph of y is equal to x plus 2 plus 1 over x minus 1 first. So for this graph, it will have two asymptotes. One is x is equal to 1. The other one is xy is equal to x plus 2, an oblique asymptote. So let me do a quick sketch here. So let's say this is the y-axis, and for the x-axis, let me sketch it here. Okay, we have y-axis and x-axis. Let me sketch the vertical asymptote, x is equal to 1. So I'm going to use dotted line to sketch the vertical asymptote. This is x is equal to 1. And as for the oblique asymptote, y is equal to x plus 2. It is going to be having a positive gradient, and it is going to be intersecting the y-axis at 0, 2. So it is going to be something like this. Okay, this will be my oblique asymptote. Y is equal to x plus 2. And if we were to press this into the calculator, press the graph of this y is equal to x plus 2 plus 1 over x minus 1 into the calculator, based on the shape that is given to me by the calculator, we will have a part of the graph like this, where the minimum point, okay, let's say here is the minimum point. So the coordinates of this minimum point here is, from my calculator, is 2, 5. Then there's another portion of the graph which is going to be over here. And for this graph, let me just do a sketch of it. For this graph, you'll realize that the maximum point is actually here. Okay, right on the y-axis. So this is the maximum point. Come back down, we have this. So this point here has a coordinate of 0, 1. Okay, this is the maximum point of the curve. So this curve over here is the graph for y is equal to x plus 2 plus 1 over x minus 1. We have the other graph to sketch. For the other graph is the graph of y is equal to modulus of 2x plus 2. We can definitely press it into the calculator. We should be pressing this into the calculator. And for that graph, it is going to be a V shape. From the calculator, we can also deduce it, because it is just sketching the graph of y is equal to 2x plus 2. Then we reflect the portion that is below the x-axis about the x-axis. So the graph is going to look something like this. From here, okay, it's actually going to be passing through this point, because it will share the same y-intercept as this. Okay, so we have this from here. Let's say here. So it's going to be passing through this here. Okay, passing through the same point when the oblique asymptote cuts the y-axis, and it shall continue. So let's say this. Okay, it shall continue. Oops, I think this is a little bit confusing. So let me just do a quick arrow to say that this is indicating for this, okay, not for this. And the other portion is going to be this. Not exactly straight, but this is the graph of y is equal to modulus of 2x plus 2. We are supposed to indicate all the coordinates. Okay, I realized I've forgotten to indicate this point here and this point here. Let me let me do it now. So from the calculator, this point here, this particular point here, it will have the coordinates of negative 1.62 and 0. As for this point over here, let me indicate it here. So this point over here is 0.618. and 0. And as for this point here will have a coordinates of -1 and 0. This point here is 0, 2, which coincides with the y-intercept of the oblique asymptote. Okay, have I indicated all the points? Okay, I have. Next, let's proceed. Hence, the question says, solve the inequality where this x plus 2 plus 1 over x minus 1 is supposed to be bigger than the modulus of 2x plus 2. So this is the inequality that we are supposed to be solving after we have sketched the graph. So we can see this as if us looking at this as the y coordinate for the curve. So I'm going to call this, let's say, y1, okay, or at least we are going to see it as if it is a y1. As for this, I'm going to see this as a y2. So this is like y2. So what this statement is requiring us to find is the range of values of x such that y1 is bigger than y2. The range of values of x such that y1 is bigger than y2. When will it happen? So the y coordinate that is on the curve is going to be more than the y coordinate that is on this v-shaped graph. And what we need to do is to find this, because this is where the curve is above the v-shaped graph. So this is going to be the region that we want. Is there any more region where the curve is more than, is the y coordinate of the curve is more than the v-shaped graph? Yes, it is another portion. There's another portion, and that is going to be this portion here. So we have two portions, one here, the other one is here, where the y coordinate is more than this. And the thing is, the question doesn't want us to press the calculator, because that will be the most ideal, not ideal, but that will be easier, because we can just press in our calculator to find the intersection between the points. But the question wants our answer in the exact form. So we have to solve it algebraically. So to do that, we are going to let x plus 2 plus 1 over x minus 1 be equal to modulus of 2x plus 2. So let's find the x coordinates of the intersection. There are three of them, this. So we'll have 2, because this is going to be like plus or minus 2x plus 2. So we'll have two equations, x plus 2 plus 1 over x minus 1 is negative of 2x plus 2. Or the other version will be when x plus 2 plus 1 over x minus 1 is going to be positive. So just simply 2x plus 2. Let's solve for this. We are going to bring this over to the left-hand side. So bringing this over to the left-hand side, we have 2x plus x is going to be equal to 3x. Then bring this over, we have 2x plus 2, it is going to be plus 4. Plus 1 over x minus 1, this is going to be equal to 0. I'll multiply this throughout by x minus 1. This is going to be 3x plus 4. Multiply by x minus 1 plus 1. This is equal to 0. Expanding this and combining with this, we will have a 3x squared plus x minus 3. This is equal to 0. Solving for x using the quadratic formula, it is going to be minus b plus or minus square root of b squared minus 4ac divided by 2a. This gives us a minus 1 plus or minus square root of 37 over 6. Okay, we have one set of answer here. Let's find the other one. So for this, we will have okay, I'm going to bring this over to the left hand side also. So okay, if I bring over to the left, I'll have a negative x. So why not bring this over to the right hand side? So 2x minus x, I'm going to be getting an x. 2 minus 2 is going to be 0, minus 1 over x minus 1. This is equal to 0, multiplying throughout by x minus 1, we have x. X minus 1 is equal to 0. So we have x squared minus x minus 1. This is equal to 0. Solving for x, it will be minus b plus or minus square root of b squared minus 4ac divided by 2a. And x is going to be equal to 1 plus or minus square root of 5 divided by 2. Okay, we do need to assign, because we have 4 answers here, we do need to assign 3 of them to the 3 coordinates here. So what I will do is I'm going to just press it in my calculator, but I'm not going to display it to my solution, definitely. So for this, we'll have two values. -1 minus square root of 37 divided by 6 gives me a minus 1.1805. And -1 plus square root of 37 over 6 gives me a 0.84713. The same goes for this. I'm going to just press into the calculator, okay? Positive 1 minus square root of 5 divided by 2 gives me a negative 0.61803. And -1 plus square root of 5 divided by 2 gives me a positive 1.61803. Then I'm going to assign based on the other values that I can compare it to. For example, this is a positive value that is bigger than 1, which is synchronized to this. X is equal to 1 here. So this must be a value that is bigger than 1 because there are two positive values. So I'm going to use this. Okay, this is definitely not this positive value. It is going to be between 0 to 1. So this value here is going to be this, which means that it is going to synchronize to 1 plus square root of 5 over 2. As for this negative values, negative, we are only going to be looking at either this or this. Okay, so this. Oh, there are only two options. So this must be the bigger value. So this is obtained from 1 minus square root of 5 over 2. As for this over here, it's going to be obtained from -1 minus square root of 37 over 6. Okay, now we have our answers. My answer is going to be a region that is between this number and this number. So therefore, let me write my answer here, okay? So x is going to be between -1 minus square root of 37 over 6 and 1 minus square root of 5 over 2. Or the other region is going to be this, between x is equal to 1 and 1 plus square root of 5 over 2. So the other region is going to be all 1. X is going to be between 1 and 1 plus square root of 5 over 2. Is this all for this question number 6? Oh yeah, it is all. We can move on to question number 7. Okay, let's take a look at question number 7, which I personally find is a very confusing question. I definitely pray that I will not see a lot of such questions in an exam. It is confusing not because of APGP. It is confusing because of the more algebraic part of the solution. Anyway, let's give it a try. Question number 7a. An arithmetic sequence A1, A2, A3 has a common difference and so on. Okay, it has a common difference of D, where D is a negative number. The sum of the first n terms of the sequence is denoted by Sn. So Sn is going to be equal to, let's just apply the sum of AP. So it will be n of terms divided by 2 of the first term plus n minus 1 times the common difference. So we have this. And it is also given to us that modulus of A8 is equal to modulus of A13. Okay, so okay, we need A8. A8, this is equal to A1 plus 8 minus 1, which is 7 times D. We need A13. So A13, this is equal to A1 plus 13 minus 1, 12 times of D. And we are also given that the modulus of A8 is equal to the modulus of A13. We are supposed to find the value of n such that Sn here is the maximum. I think this question requires quite a bit of exploration. That means we'll be required to not be able to see the whole strategy of how we are going to be solving the solution, but we're going to try to explore along the way. I think that is the nature of this question. So let's not be intimidated because we are not able to charted out the full path towards our solution. So let's just see what we can do along the way. Okay, so since this is given to us, I'm going to replace this A1 plus 7D. Modulus of this is equal to the modulus of A1 plus 12D. So I'm going to split this up into two. By removing the modulus, one of it is going to be A1 plus 7D is negative of A1 plus 12D, or another possibility is A1 plus 7D is equal to positive A1 plus 12D. A1 and A1 here can be cancelled. If I were to bring this over to the right hand side, we will have a 5D is equal to 0, which tells us that D is equal to 0 and D cannot possibly be equal to 0 for an AP, or else every single term of this AP is going to be A1, 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 A1. So there's no behavior of arithmetic progression at all. So this is not possible. My answer should be, my solution should be continued from here. So A1, there's another A1 here. So we can bring both over to the left-hand side, which will give us a 2A1, and bring 12D minus 12D over to the left-hand side, we have a plus 19D. This is equal to 0. Okay, what should I do if I'm faced with this? So I guess for this, okay, let me just do a quick change to this. 2A1 is equal to minus 19D. At least I see a 2A1 here. And the reason why I am looking at this is definitely because the question is not exactly interested in A1 or D. The question is interested in Sn experiencing its maximum. So let's look at Sn. Okay, and since this is sort of like something that I've explored, I'm going to try to put this back into here to see whether it's going to work. So we have a n over 2 of 2A1, which is minus 19D, plus n minus 1 times D. Okay, we have this, which means that we can actually factorize out D. Okay, let's factorize out D. If I were to factorize out D, it is going to be D over 2 times n of this. How about me multiplying n in? So we have a minus 19n, then plus n minus 1 times n. Okay, I think we have gotten something over here, because this is going to be this. And this, if I were to just simplify it, we will have a n squared minus 20n. And what is this? This is a quadratic expression in terms of n. And here we have a constant. So Sn is equal to this, and we have a quadratic multiplied by a constant. It is almost like this, okay? It is almost like having a x squared minus 20x multiplied by a constant, and we don't know what is D, but we know that D is less than 0. That's what the question says. So we are looking at something that is like this. And what is something that is like this, according to what we have learned in our secondary school? It is going to be a set phase. So it will have a maximum. And how do I get a maximum for a quadratic expression that is like this? We complete square, right? That's what we have learned in our secondary school. So that's what I'm going to try do next. This constant, I'm going to just let it be. I'm going to complete square to this, which will give me a n minus 10 square minus away 10 square. So we will have a d over 2, which is a negative number, n minus 10 square minus away 100 divided by 2 is going to be 50d. So we have Sn to be in a quadratic form, and it is in a completed square form, which means that we have a set phase. Again, why set phase? Because D is negative. We have a set phase with a maximum point. And how do I find this maximum point? I read it from the completed square form, and that is when n is equal to 10 and Sn is minus 50d. So what the question asks for is, what is the value of n such that Sn is the maximum? So that is how I can answer it now. Therefore, Sn is maximum when n is equal to 10. 7a. Okay, it is a question that requires exploration, and I think there's even more exploration in part B. When I was trying part B myself, I thought it is confusing. Okay, we need to try out a little bit here and there. So I do believe that there are a few different variations that you guys can probably be trying and getting the answer for part B. So I'm just presenting one of them on the board according to what I've tried. So according to the question, The terms u1, u2, u3, they are three consecutive terms of a geometric progression, which means that u2 over u1, this is going to be equal to u3 over u2. Okay, we can do a little bit of manipulation to this definitely, which is if I were to cross multiply, we know u2 square is equal to u1 times u3. I'm going to just leave it as it is first, okay? Next, it is given to us that u1, u2, and u3 minus 32 forms an arithmetic progression. So if it forms an arithmetic progression, that means u3 minus 32, this minus the previous term, which is u2, this should be the same as u2 minus away u1. We can also try to simplify this a little bit. Nothing much that I can actually do. But just by rewriting this, we have a u3 minus 2u2 plus u1 minus 32. This is equal to 0. I'm going to leave it as it is for now. And then u1, u2 minus 4, and u3 minus 32. These are going to be forming a geometric progression, which means that u3 minus 32 divided by the previous term, which is u2 minus away 4, is equal to u2 minus 4 divided by the previous term, which is u1. I'm going to, just like what we did here, cross multiply. So if I were to cross multiply this, we will have a u1, u3 minus away 32, u1 is equal to u2 minus 4 square. So it's going to be equal to u2 square minus away 8 u2 plus 16. Okay, there's also nothing much that we can do here. So I am going to just try to see whether I can form an equation with just one unknown. I don't think it is actually possible, but I'm going to just put this in. Okay, u1, u3 is equal to here. So I'm going to replace this by u2 square. At least I will have an equation with just u1 and u2 after that. So if I were to replace this, will be u2 square minus away 32 u1 is going to be equal to u2 square minus 8u2 plus 16, which I don't think we can do much about it for now, other than u2 square and u2 square can be cancelled. If I were to bring all the u's to the left-hand side, then we will have 8u2 minus 32u1 is equal to this 16 that is left. u2 will be cancelled away. And I'm going to divide throughout by 8, which will give us a u2 minus 4u1 is equal to 2. Again, we are sort of like stuck. So I don't think we will be able to proceed much as of now with these three equations that we have here. So why not let's break it down further? Because we know that u1, u2, u3, they follow a geometric progression. So I'm going to go for that geometric progression at this GP, right? With the first term as A and the common ratio, I'll let it be R. So if I were to do that, at least I know that this u3 is going to be equal to AR to the power of 3 minus 1, which is 2, minus 2AR plus A minus 32. This is equal to 0. And from here, I can actually see a common term, which is A. So we have R squared minus away 2R plus 1 minus 32. This is equal to 0. And if I were to try this, okay, if I were to try to break this into A and R, I say like re-express this into A and R, we have a AR minus 4A. This is going to be equal to 2, which means that A is going to be equal to 2 over R minus 4. This is actually pretty good, because if I have this, and I call this, let's say, equation number 1, and if I were to call this equation number 2, which I probably should have equation number 1, 2, 3 earlier, okay, but anyway, we're exploring, so just pardon my weird presentation here. So I have this, and I'm going to then substitute this equation number 2 back into equation number 1, so that I can have an equation that is in terms of r. Okay, so a is going to be replaced by 2 over r minus 4. So we have a 2 over r minus 4 multiplied by r squared minus 2r plus 1 minus 32. This is equal to 0. I'm going to multiply this equation throughout by r minus 4. This gives me a 2 times of r squared minus 2r plus 1 minus 32 of r minus 4. This is equal to 0. So we have a r squared minus 2r plus 1 minus away. This is going to be 16 of r minus 4. This is equal to 0. Simplifying this further, we have a r squared minus 18r plus 65 is equal to 0. We will get a r minus 5 and r minus 13 is equal to 0. This tells me that r is either going to be equal to 5 or r is going to be equal to 13. Nice, because with this, I can then find a. When r is equal to 5, we have a 2 over 5 minus 4. So we have a 2 over 1. So a is going to be equal to 2. When r is equal to 13, we have a 2 over 13 minus 4. So a is going to be equal to 2 over 9. And now we can find u1, u2, u3. So let me use the first set of a and r. When a is equal to 2 and r is equal to 5, u1 is going to be equal to a, which is 2. u2 is going to be ar, which is going to be equal to 10. And u3 is going to be ar squared, which is going to be 2 times 5 squared is going to be equal to 50. So we have the first set of u1, u2, u3. The other set is going to be coming from when a is equal to 2 over 9 and r is equal to 13. So u1 is going to be equal to a, which is 2 over 9. u2 will be a multiplied by r. This is going to be equal to 26 over 9. And u3 will be a multiplied by r squared. And this gives me a 338 over 9. Okay, this is question number 8. And next, let's go for question number 10 over here. Okay, 10 is Next, let's go for question number 8. We have just finished question number 7. So question number 8 over here, okay, goodness, is a pretty long question. Let me adjust this a little bit. Okay, so this is question number 8. Yep. Okay, let's take a look at this question. Okay, we have this graph over here. It is given to us as a graph of y is equal to fx. And I fill in the coordinates of the points that are given. My version is definitely more messy than the one that is given to us by the question. So, but let's refer to both, okay? Because at least for mine, I planted the numbers in directly, so it is for easier reference. So part 1a, we are supposed to be sketching the graph of y is equal to f modulus of x. So to sketch this graph, we are going to be ignoring this part of the graph in the original graph. Then we're going to draw this part, and we're going to reflect this part over to the left-hand side about the y-axis. Okay, so that is the transformation that we have learned. So let me try to draw the y-axis first and then the x-axis. So y-axis, and we have an x-axis. I'm going to draw it a little bit bigger than that so that I can fill in all the numbers. So x-axis is here. So we have this. I'm going to draw just this part of the graph. So we have a vertical asymptote. And this is x is equal to 3. We have that oblique asymptote. So it's going to be this, starting from 1, right? That is the y-intercept. So I know this is at 1. So starting from 1, we have this. So this line is y is equal to x plus 1. Let's sketch in the graph. So we have this part that I'm going to be sketching in. And this point here is going to be at a point 5, 8. And as for the other part of the graph, it is going to be something like this. It will be like this, coming up here, making a turn at the maximum point 3 over 2 and 3 over 4. Then coming back down to the point 2, 0. Then going towards the vertical asymptote x is equal to 3. So this point here is the point 2, 0. And this maximum possible point here, this point here is 3 over 2, 3 over 4. And I want to make sure that this is going to be a point where it cuts the y-axis at an angle. Okay, the tangent is cutting it at an angle. So I'm going to be reflecting this about the y-axis and ignoring the original portion of the region where x is less than 0 for this particular transformation. So let's again sketch the asymptotes first. Okay, it is always a good habit to sketch in the reference lines first before we sketch in the rest of the graph. So this vertical asymptote x is equal to 3, it is going to be reflected. Let me sketch it down here. Dotted lines will be representing reference lines. So this is x is equal to minus 3. This oblique asymptote, let's reflect it. So we have this. Okay, it is a reflection about this line. So x is going to be replaced by minus x. So for the oblique asymptote, y is minus x plus 1. So this is going to be reflected. Let me sketch it. So we have this. Okay, and the minimum point here will be minus 5 and 8. Okay, we are going to reflect this. Okay, I'm almost tripping. So I'm going to reflect this. So this is going to be something like this. Maximum point and then coming down, then all the way. So this maximum point here will be a reflector point for this. So for this, the coordinate will be negative 3 over 2 and 3 over 4. As for this point here will be at minus 2 and 0. So this will be the graph. There's still one more point that I'm supposed to be adding in. Should I be adding in that point? Okay, no. Okay, I thought we had the coordinates for this, but we don't. So, okay, this is the graph that we are going to be having. The graph of y is equal to f modulus of x. Next, let's sketch the other one. The graph of y is equal to 1 over x. So let's take a look at one part B, where we are supposed to be sketching the graph of y is equal to 1 over fx. Let me draw a bigger graph for this. So let's say here we have the x-axis, and as for the y-axis, let's draw here. Okay, let me go for this as the y-axis. So with the x and y axis, let us try to do a sketch of the graph of y is equal to 1 over fx. We have a very, very effective strategy that we have been using at tuition. So I'm going to use that same strategy here. We're going to be, for that strategy, we are going to be using a little bit of memorization work, and then we're going to be using some analytical work. Okay, I think this combination is the best possible and the most effective possible way to be sketching the graph of y is equal to 1 over fx, giving us precision and consistency during the exam. So the memorization work will be memorizing some features for the transformation that is pretty consistent. For example, we can memorize points that are cutting the x-axis. The points that are cutting the x-axis here will become vertical asymptotes. Okay, so I'm going to execute that. So for this point and this point, they will become the vertical asymptote. So we have a vertical asymptote at x is equal to minus 1 here, and we have a vertical asymptote of x is equal to 2 here. So let me draw these two lines. So here, let's say this. Okay, let's say this is x is equal to minus 1. That is based on this point here, x is equal to minus 1. Then we have x is equal to 2, which is based on this point here. X-intercept will become vertical asymptote. So we have this. So here, x is equal to 2. Then we are going to look at the asymptotes that are here and see how they are going to be transformed. There are 3 asymptotes here. I'm going to work on the 2 vertical asymptotes first, because vertical asymptotes will become x-intercept. That is because we have already memorized it. Of course, we can derive meaning through it, but for efficiency, for timing's sake, these are very consistent features that we can memorize. X-intercept becomes vertical asymptote becomes x-intercept. So we will have two x-intercept. One is when x is equal to -2. I'm going to do a quick sketch, quick point here. So let's say it is here. Okay, so this will be at -2, 0. The other point is going to be based on this x is equal to 3. So let's say it is going to be, say, here. So here is 3, 0. And that's an oblique asymptote. Oblique asymptote, it actually can be memorized also. Oblique asymptote, when it goes through the transformation, it is going to become a horizontal asymptote of y is equal to 0. But let's try to go for a more analytical approach for this oblique asymptote, since most schools also don't have a set of rules for oblique asymptote. Okay, so we are going to try to analyze it on the spot. Okay, but if it is possible, I think it is also good for us to just memorize that oblique asymptote will usually become a horizontal asymptote of y is equal to 0. So with this that are done, I'm going to just do an analysis from the left to the right. Okay, there are even more detailed steps that we have discussed in tuition. You can definitely follow those steps. But anyway, for this, I'm going to just go from the left to the right doing an analysis. How do we do our analysis? We will assign arbitrary points to the graph here, and we will transform those points. What do I mean by transforming those points? For example, a point that is like this. A point that is like -3 and -3. This point is going to be transformed to, on this graph, the y coordinates that on this graph is 1 over the original y coordinate, which is fx on this graph. So this point is going to be transformed to -3 and -1 over 3, because we are doing a 1 over the original y coordinate. So that is a transformation that is taking place. If you were to go all the way to the left, if I were to put a point that is, let's say, here, all the way to the left, okay, and I'm going to assign to it an arbitrary coordinate, since we sort of like have a feel of coordinates, right? So all the way to the left, and a point that is all the way at the bottom, can be a point, an arbitrary coordinate of -100 and -100. So this point will become a -100. The x coordinate remain the same. The y coordinate, it will be 1 over -100. So 1 over -100 is -0.01. So I'm going to poke this point here. That point is going to be somewhere, let me just extend this a little bit. That point can be somewhere here, -100 and -0.01, representing this point. Then it's going to go to this point, which is -3, -3 towards the right, and it will be transformed to -3 and -1.3. I'm going to go for that point to be, let's say, somewhere here. So this point will be -3 and -1 over 3. So this point here should be -1 over 3. So from here, we are going to connect it to this point here. And we are going to continue to join it to a point that we have already decided previously. So it is going to be a point here. And since for this point, okay, if you just think about it, as it continues to the left, the y coordinate will just continue to become more and more negative. And 1 over that negative y coordinate will just be nearer and nearer to 0, but you will never ever touch 0. That is why for this, it will just go nearer and nearer to the x-axis, but you will never ever touch the x-axis. That is why we will get a horizontal asymptote of y is equal to 0. Oblique asymptote will become a horizontal asymptote of y is equal to 0. So anyway, coming back to here, as we progress towards -2, as we progress towards -1, we have already moved past -2, -2 is here. As we progress towards -1, we are interested in how the graph is going to be looking like. So just to the left-hand side of -1, I'm going to mark a point that is here. Usually this is just going to be going through my imagination. So this is, let me assign an arbitrary coordinate to it, okay? So let's say the x coordinate is somewhere slightly to the left, so -1.1. The y coordinate is a positive value, 0.01, which will become -1.1, and this will become +100. So I'm going to mark this point as if it is really a -1.1 and 100. -1.1 and 100 is going to be here, the point that is here. So I'm going to connect again. So from here, I'm going to just continue and connect it to a point that is here. The same goes for a point that is on the right-hand side. For example, here, just on the right-hand side of x is equal to -1, just on the right-hand side of x is equal to -1, we have a point that is -0.9, an arbitrary coordinate being assigned to it. the y coordinate, I'm going to go for the same thing, which means that it's going to be negative 0.9 and a positive 100. So negative 0.9 and positive 100 gives me a point that is here. Then it's going to go to this point, which will be transformed to 3 over 2 and 4 over 3, because we reciprocal the y coordinate. So we'll have a point that is, let's say, here. Okay, let's say here. This point is going to be 3 over 2 and 4 over 3. Okay, from 3 over 4, it becomes 4 over 3. So from here, it comes down, joining to this point that is here. Then it will continue to go towards 2. As it goes towards 2, 2 is here. So as it goes towards 2, when it is near to 2, I'm going to put a point that is slightly to the left-hand side of 2, as if that point has a coordinate of 1.9 and 0.01, which will be transformed to 1.9 and 100. So if I were to poke a point, 1.9 and 100, it is going to be somewhere here. So from here, this minimum point here is going to turn up all the way to here. So this is where my minimum point is. This is where the other minimum point is. And to the right-hand side of 2, so let's say a point that is here, I'm going to go for, let's say, 2.1, and I can see that the y coordinate is probably a large negative value, which is near to the x-axis. So this is going to become a 2.1, and 1 over negative 0.01. It will be minus 100, a very, very negative value, which means that it is going to be here, 2.1 and negative 100. Then after that, coming back to this point here, we are going to go back up, touching this point here. Then going to this point, what is it going to be? 5 and 1 over 8. So it is going to be somewhere here. 1 over 8 is less than 4 over 3. So let's say from here, it will go to this point, which is going to be 5 and 1 over 8. And it will just continue all the way to this point here, which we know that there's going to be a horizontal asymptote, so it's likely going to come back down here. But let's just do a quick verification. So for that particular point, I'm going to assign an arbitrary coordinate also. So let's say 100 for a value that is all the way to the right, and all the way to the top, 100, which will become a 100 and 0.01. So it will become a point that is maybe somewhere here. So from this point, I'm going to just go back down, curving it a little bit, tending towards the horizontal asymptote. And this is very effective, and in fact, it can be very, very fast, because as we are trying it out as we are attempting this during the actual exam, we don't really need to write down this. So this is just rehearsed in my head multiple times, how we are transforming points to points, points to points. That is why we get a lot of practice for this, and that is also why I'm pretty confident that this, if you have practiced this well, it can be done very, very fast and very, very accurately during the exam. Let's look at the next part of the question. Part 2, by drawing another suitable graph on the same diagram as this, determine the number of solutions to that equation. Let me erase this. Let me do it here. So in part 2, we have this equation, x squared over 36 plus 1 over 16 of fx squared. This is equal to 1. So what kind of question is this? This is actually a simultaneous equation question. We have discussed this during tuition also. So to look at this as an equation itself, it may not be easy for us to solve it, but to look at this from the perspective of simultaneous equation, it just brings our perspective to one that is to one that we can have a bit more foresight to what exactly is happening, or rather it gives us some background of how we can actually solve this question. It provides for us a framework. So what do I mean by the simultaneous equation? Because I know that there are two equations that are going to be combined to form this. One is going to be from here. Okay, and this is the graph of y is equal to 1 over fx. So if one of the equation is y is equal to 1 over fx, this is equation number 1, because the question requires us to refer this back into part B, okay, which is this. So my aim is to find out what is the second equation when they're such that when they're combined together, I'm going to be getting this. So for the second equation, if you were to look at what that is here, can you see that if I were to just do a bit of manipulation, for example, like this, this is going to be equal to 1 over fx squared over 16. this is equal to 1. So now from the perspective of simultaneous equation, can you see that the second equation is going to be x squared over 36 plus y squared over 16. This is equal to 1. Okay, that is why if you were to look at it from the simultaneous equation perspective, we know that the second graph that we are supposed to be sketching will have an equation of x squared over 36, which I'm going to write it as 6 squared, plus y squared over 16, which I'm going to be writing as 4 squared, is an ellipse. It is an ellipse with the center at the origin, and it has a horizontal radius of 6 and a vertical radius of 4. So we have an ellipse that is supposed to look something that is like this: minus 6, 6, negative 4, 4. So if I were to sketch this ellipse here, and hopefully it is going to look like an ellipse. Okay, I'm going to just draw it freehand. So the origin is going to be here. Okay, so the center of the ellipse is going to be here. Negative 6. Okay, you will go all the way past negative 3. Negative 6, let's say somewhere is here. Negative 6 is going to be even to the right hand side of the highest possible point here. So okay. So it is going to be, let's say here. This is, let's say, 6 and all the way to the left. Okay, about the same distance. So let's say here is my minus negative 6. Okay, then 4, minus 4 and 4. So negative 4 is definitely going to be way below. So negative 4, let's say, is here. Positive 4 is going to be way on top. Okay, I think my graph is definitely out of scale. But anyway, with this idea, if I were to just join them together, okay, to form the ellipse here, then from here it's going to come down here, right? So from here it's going to come down to here. This point is supposed to be very, very low, 1/8. So you will never actually cut the ellipse. The same goes for this. This is supposed to be very, very negative 1/3. It's supposed to be very, very near to the x-axis. So it will be this, then coming down. Oops, I almost overshoot. So I'm just going to come down to here. Then it's going to go back to here. So here is my out of shape ellipse. And based on this, because we are working it as a simultaneous equation question, so the solution to this equation is going to be the x coordinates of the intersection between these two graphs, right? That's simultaneous equation. So where are the intersections? It's going to be here, 1 intersection, here 2, here 3, here 4, and we have a 5. Do we have any more? I've missed one, which is here, 6. So we have 6 intersections. Because there are 6 intersections, so we can now conclude that the number of solution, the number of solution to this equation that is given to us is the number of intersections here is 6. Okay, next, let's look at question number 9. Okay, let's take a look at question number 9. So Harry and Tom, they are playing this model airplanes, and according to what the question says, the position of Harry's airplane is going to take up the form of that equation that is given to us. It is the equation of a line where t that is given to us represents the represent the time. It is representing the time in seconds since Harry's airplane takes off. So I'll represent the position of that plane. The same goes for Tom. The equation of the position vector of the airplane for Tom is also given to us. So we know that the two planes, they are flying in a straight line because the two equations that are given to us are straight line equations. Part 1, we want to state the height of Harry's plane 2 seconds after it takes off and find the distance that he has traveled for the first 2 seconds. So for 2 seconds, according to the question, since t that is given to us is representing the time that it takes since it takes off, that means t is going to be equal to 2. And for Harry, I'm going to let, part 1, I'm going to let LH represents the path of the airplane. So the position vector of the plane is given to us as this, 5, 6, 0. Interesting for us to take note that 0, because the question told us that the plane takes off from the horizontal ground, and the horizontal ground is the XY plane. So if you to look at this, the height is 0. The z, okay, is 0. Okay, that's why when it takes off, t is equal to 0. The position is at 5, 6 on the ground. Then anyway, this plus t, we will have a minus 4 to 4. So 2 seconds later, that is when t is equal to 2, then the position vector of the plane will be at 5, 6, 0 plus 2 times of negative 4 to 4. And this is equal to negative 3, 16, 8. This is the position vector of the plane, but the question is only asking for the height of the plane. So the height of the plane, the height that is experienced by the plane is going to be just this, the z coordinate of the plane. So therefore, height that is required by the question is going to be 8 meters. Find the distance traveled in the first 2 seconds. So we already know its position vector during the second second. So let's try to look at its position vector when it was still before it takes off. So when t is equal to 0, that is before it takes off, r is going to be equal to just 5, 6, 0. So if I were to just visualize this whole thing as if it is a line h where it started off at this point 5, 6, 0, which I'm going to call it point A, and 2 seconds later it is at point B, which is minus 3, 16, 8. Then this is going to be the distance of the plane. This is the distance that the plane has traveled in 2 seconds. So the distance that is required by the question is going to be modulus of AB is going to be modulus of OB minus OA. So negative 3, 16, 8 minus away 5, 6, 0. This is equal to the modulus of negative 8 for 8. It is square root of negative 8 square plus 4 square plus 8 square. It is going to be square root of 144. So the distance that is traveled is going to be equal to 12. Then part 2, find the acute angle that is between the path of Harry's airplane and the ground. So Harry's airplane, this LH, and the ground, let's say this here is the ground. In order for us to find this angle here, I'm going to call this angle here theta. We're going to reference it to not the vector that is on the ground, but the vector that is perpendicular to the ground. The vector that is perpendicular to the ground is 0, 0, 1. The vector that is parallel to the line LH is obtained from here. It is negative 4 to 4. So we're going to try to make use of this to find theta. So by making use of the dot product, it is going to be modulus of 0, 0, 1 dot negative 4 to 4 modulus. This is equal to modulus of 0, 0, 1 modulus of negative 4 to 4. Then cosine of this angle, which is 90 degrees minus away theta. We are putting an overall modulus here just to make sure that we force all the angles that we are working on to become an acute angle, which is what the question is trying to say. So anyway, here is just going to be modulus of 4, which is equal to 4. This is going to be square root of 0 square plus 0 square plus 1 square is going to be square root of 1. This is going to be square root of 4 square plus 2 square plus 4 square. It is going to be square root of 36 cosine 90 degrees minus theta. So cosine 90 degrees minus theta is going to be 4 over 6, which is going to be equal to 2 over 3, which means that theta is going to be equal to 90 degrees minus cosine inverse of 2 over 3. Pressing this into the calculator, we are going to be getting a 41.8 degrees. And in part 3, I still have some space, let me just write it down here. In part 3, we are supposed to show that the path of the two airplanes, they are perpendicular to each other. For Tom's airplane, I'm going to let this path be LT. And according to what the question has mentioned to us, R is equal to negative 36, and the other one is 44. And 0 for the Z, again, Tom's airplane starts from the ground. Okay, that is why the Z coordinate is equal to 0 plus S, which represents the time that is taken for the airplane that is flown by Tom to be taking, so S time 4, -6, and 7. So to prove that they are perpendicular, I'm going to make use of this, I'm going to make use of this. So I'm going to just take -4 to 4 dot 4, -6, 7. This is going to be equal to -16, -12 plus 28. This is equal to 0, therefore their paths are perpendicular. Okay, this is part 3. Let's move on. So we know that the path that the airplane, the path of Harry's airplane is this, and the path of Tom's airplane is R is equal to -36, 44, 0 plus S of 4, -6, 7. And in part 4, we are given that the two airplanes collide. Okay, set. Find the coordinates of the point of collision. So the two planes are supposed to be sharing the same position vector in order for the collision to take place, right? So we're going to solve this as a pair of simultaneous equation where R is going to be equal to R. So we're going to let 5, 6, 0 plus T of -4 to 4 be equal to this, which is -36, 44, 0 plus S of 4, -6, 7. So I'm going to let this be equal to this based on the first row. We are going to be having a -4t. And this, if I have to bring over to the left hand side, -4s. 5, if you have to bring over to the right hand side, this is going to be -44. This will form for me the first equation. Based on the second row, we will have a 2t plus 6s. This is equal to 38. This is my second equation. And based on the third row, we will have a 4t minus 7s. This is equal to 0. And we're going to solve this as a simultaneous equation by pressing into the calculator. So from the graphing calculator, solving this as a simultaneous equation, we're going to get t to be equal to 7 and s to be equal to 4. This, let's take note, these are the time that is taken by the airplanes to be flying after they have taken off. So we are supposed to find the coordinates of the collision, right? So at the time when they collide. So at collision, t is equal to 7 for Harry's plane and s is equal to 4 for Tom's plane. We can either use 7 or 4. Let me just use 7. So at the point of collision, R is going to be equal to 5, 6, 0 plus 7 times of -4 to 4, which is going to be equal to -23, 20, and 28. So this gives me the position vector of the point of collision, but the question 1, the coordinates. So the coordinates of collision is, let me just write down, collision, it happened at the point -23, 20, and 28. How long, the question asks, after Harry's plane take off, does Tom's plane take off? So they collide at the point when t is equal to 7 for Harry, s is equal to 4 for Tom, which means that the difference, which is 3 seconds, is going to be the time between the takeoff by the both planes. So based on this, I can say that Tom's airplane took off 3 seconds after Harry's plane. Okay. And the last part 4, part 5. Part 5 is a very, very easy question. We are supposed to find the Cartesian equation of the plane that carries both airplanes. So anyway, it is a Cartesian equation that contains these two lines. We can find the normal by taking the direction of the two lines and cross them together. So we have 4 minus 6, 7. Okay, the direction of this cross the direction of this. Since these two lines lie on that plane, that the question 1, this cross this will give us the normal vector, which is 38 and 44 and 16. I can factorize out 2, which gives me a 19, 22, and 8. So I can use this as the normal vector to the plane, or I can also use this. I'm going to use a smaller number. So the equation of the plane, okay, this plane is a surface. Okay, it's different from this plane definitely. So anyway, the equation of the plane will be r dot 19, 22, 8. This is going to be equal to the position vector of a point that is on the plane. Since these two lines lie on the plane, this should be a position vector of a point that lies on the plane, this plane. So I'm going to use 5, 6, 0 dot 19, 22, 8. So this will give me a 2, 2, 7. So the Cartesian equation is, by replacing r by x, y, z, the Cartesian equation is 9x plus 22y plus 8z. This is equal to 2, 2, 7. The last question, question number 10. Okay, yep, this is the last question. Let's try this functions question. Okay, so this question number 10, we are given two functions. One is f, so let me write it down. F is such that x is going to be processed by the expression of this, where the domain is all real numbers and k is a constant. And then for the graph of g, let me just write it down here. So for the graph of g, g is going to be this 9 over 2 minus x, where x is all real numbers, but x cannot be equal to 2. Part 1. Part 1, we are looking at a composite function gf, and we are supposed to explain why the composite function gf does not exist. We're going to use the same schematic as what we have used in tuition, what we have used on Achevas TV. So the composite function gf, so we can visualize it as if it is this, where two functions are being joined together. First goes into f, then after that goes into g. So into f, then after that into g. So in order for the connection to take place, in order for the composite to take place, we want to make sure that everything that comes out from f, the range of f, they must all be able to be received by g, the domain of g. So we do have the domain of g. The domain of g is all real numbers except 2. We don't have the range of f. So in order for us to find the range of f, we are going to try to look at a graph of this. And for the graph of this, it's actually just a straight line. K is a constant. So looking at the graph of f, it's going to look something that is like this. Positive gradient with this point here as 0 and negative 2k. We don't even know whether k is positive or negative. Okay, so I'm not going to draw the x-axis because I don't know whether it is going to be above the x-axis or below the x-axis, but I know this is going to represent the graph of y is equal to fx. So looking at this, what is the range? The range is from minus infinity to infinity. What is the domain of g? The domain of g is going to be from minus infinity to 2 or from 2 all the way until infinity. So 2 that is here will not be able to go into the domain of g, so it is not going to be a subset. Therefore, the composite function gf does not exist. And in part 2, find the range of values of k for which the equation fg. So gf does not exist. We will just assume that fg exists, has real roots. So we are looking at fg. Let's try to form the expression for fg first, okay? So for fg, it is like putting g into f. So we have 4 times of 9 over 2 minus x minus 2k. This is equal to 36 over 2 minus x minus 2k. So we are going to be letting fgx be equal to x, which means that it is going to be 36 over 2 minus x minus 2k. This is equal to x, such that x is supposed to be the same as the domain of the composite function. What is the domain of fg? Is the same as the domain of g, which means that x will be all real numbers, domain of g, all real numbers, but x cannot be equal to 2 for whatever answer that we are going to be getting here, okay? So based on this, let's try to solve for x as if we are really trying to solve for x, okay? But our interest, according to what the question says, is to find the range of values of k. So if I were to solve for x from here, I'm going to multiply this throughout by the denominator, which will give me a 36 minus 2k of 2 minus x is equal to x times of 2 minus x. And I'm going to bring everything over to one side, which will then give me an x square plus 2kx minus 2x plus 36 minus 4k. This is equal to 0. Regrouping as if we are trying to solve for x, we will get a x square plus 2 times of k minus 1x plus 36 minus 4k. This is equal to 0. And since the question says that there's going to be real roots, this is going to give you roots. The quadratic equation that we have derived so far will be getting roots. It will give us solution. So for this quadratic equation to give us solution, that will be when the discriminant is bigger or equal to 0. If it is bigger than 0, then this equation is going to give us 2 solutions. If it is equal to 0, it will give us 1 solution. So we're going to let it be bigger or equal to 0 in order for us to have solution. So that will be when the discriminant, which is going to be b square minus 4ac is bigger or equal to 0. So we have a 4k squared minus 2k plus 1. Then here is going to be equal to a negative 144 plus 16k. This is bigger or equal to 0. Let me continue here. So if I were to expand and simplify this, we will get a 4k squared plus 8k minus 140 is bigger or equal to 0. Dividing this throughout by 4, k squared plus 2k minus 35. This is bigger or equal to 0. Factorizing this is going to be k plus 7 and a k minus 5. This is bigger or equal to 0. I can then now draw the number line for k. This is minus 7 and 5. If I were to sub values into the left hand side, we'll get a plus minus 5, sorry, plus minus plus. And we're looking for the region that is bigger or equal to 0 is going to be this, which means that k should be less than or equal to minus 7, or k should be bigger or equal to 5. Next. Oops, we are already at the last question here. So the next part 3, we are supposed to let the rest of the question be done as if k is equal to 5. So if k is equal to 5, it is going to be here. 2 times 5 is going to be equal to 10. So here it's going to be minus 10. Sketch the graph of y is equal to fgx for x to be strictly less than 2. And then we are going to sketch the inverse, and we're going to show the relationship between y is equal to fx and y is equal to f inverse x. So we have gotten from the previous part that fgx is equal to 36 over 2 minus x minus 2k. Okay, so k is equal to 5, so this is going to be minus 10. Or you can see this as negative 10 plus 36 over 2 minus x. So if I were to see it based on this, we know that there's going to be a horizontal asymptote of y is equal to negative 10, and the vertical asymptote of x is equal to 2. And we're going to be looking at the region where x is supposed to be strictly less than 2. So if I were to sketch the graph of fx such that x is supposed to be strictly less than 2. Okay, this is when x is supposed to be sketched as strictly less than 2. Okay, that's the criteria given to us by the question. So let's do a quick sketch. The x-axis, the y-axis. We have a horizontal asymptote of y is equal to negative 10 based on this. So this here, y is equal to negative 10. We have a vertical asymptote of x is equal to 2. Let me sketch it here. Okay, so let's say this is x is equal to 2. And we are getting just the region based on our calculator, right? The region that is x is less than 2. So, but before that, okay, I think it is also crucial since we are going to be sketching the graph of y is equal to f inverse x. On our calculator, we should be letting y1 be equal to negative 10 plus 36 over 2 minus x. But at the same time, I should be sketching this also, another reference line, which I know it is the line that the graph of y is equal to fx and the graph of y is equal to f inverse x, they are going to be reflected about. So it should be drawn on my graph, okay? So y is equal to x, I'm going to sketch it in also. The 45-degree line, so we have this. Here. Oops. So we have this. Okay, and this is my line, y is equal to x. So if you sketch these two together on your calculator, you'll realize that these two, they are actually tangent to each other. The graph is going to look something that is like this. So from here, okay, it is going to just touch. Then you will continue up, just touch. So continue up, and you'll go this way. Okay, let me extend this a little bit more so that we can see the behavior of the horizontal asymptote. So this will be the graph of y is equal to f, g, x, just touch. And it is touching at the point 4 and minus 4, which means that the graph of y is equal to f inverse x. I'm going to use red color to draw the other graph, okay, so it's easier for us to see. It's going to be a reflection of this. I'm going to reflect all the asymptotes first. There's a point. Let me just indicate all the necessary points first. I keep forgetting about this. So it is this point and this point. These 2 points we should try to indicate. This point here has a coordinates of minus 1.6 and 0. As for this point is at 0 and 8. Okay, so let me do the reflection of the horizontal asymptote, which will become here. So this will be x is equal to negative 10, vertical asymptote. This vertical asymptote, when it is being reflected about the line y is equal to x, it will become a horizontal asymptote. Okay, so we'll have a horizontal asymptote of y is equal to 2. From x is equal to 2, become y is equal to 2. And let's try to do a reflection of this about the line y is equal to x. So from here, it will be reflected up, touching at this point. Since it's a tangent point, then it will go here, here, and then moving up all the way. We're not to scale, definitely. So, and this point is going to be at 0 and negative 1.6. And as for this point is going to be at 8 and 0. And this graph that we have is going to be the graph of y is equal to fg inverse x. Okay, now we are we at the last part already? Okay, we are almost at the last part. So the next one, we are going to be looking at another function that is given to us. This function is representing the height of the mass t seconds after it is being thrown. Okay, according to the question, it is going to be thrown at a height of 3, which means that h0 is going to be equal to 3. And then when t is equal to a, the object starts to descend. A is actually also here. So you can see this is actually at the point where the transition takes place. Ascend to A, then after that descends. It will descend all the way until when t is equal to b, which means that when t is equal to b, hb is equal to 0. We are supposed to find the value of a and b. Let me erase what I have on the board first. Okay, and based on the h that is given to us, it is actually dependent on g and t. That's g and f. Okay, so let's rewrite the piecewise function that is given to us for h. So ht is given to us as a piecewise function from as a 30 over 7 plus g t plus 9. G is this. So g of t plus 9 will be 9 over 2 minus t plus 9. Okay, so this will be negative of 9 over t plus 7. So I'm going to replace this by negative of 9 over t plus 7. And this happens when t is bigger or equal to 0 and strictly less than or equal to a. So this is one part of h. For the other piece of h, it is going to be 2 minus ft. ft is that. So 2 minus ft is going to be 2 minus 4x minus 10. So this is equal to 12 minus 4t. So I'm going to replace this by 12 minus 4t. And this happens for the other piece, which is when the time is between a and less than or equal to b. So we have two pieces that is going to be defined this way. This will represent the piecewise function for ht. Like what we have just mentioned, the easier piece of information that I think we can make use of is the fact that finally the object will reach the ground level when t is equal to b. Okay, that is the piece of information here. Where is it? It is going to be this. The object will descend and finally reach the ground at t is equal to b. So we know that h, b, this is equal to 0. And when h is equal to b, we are going to be making use of this. So we have a 12 minus 4b. This is equal to 0. 4b, this is equal to 12. This helps us to solve for b directly. b is going to be equal to 3. 12 divided by 4. b is going to be equal to 3. I think a is a little bit tricky. You know why? Because we have to try to imagine, okay, the object is going to ascend, then at point A is going to descend. So if you have to look at this, that means this from 0 to A is at the ascent. Then after that, from A onwards is going to be the descent. Do you think the height will suddenly change? The height will not change, right? The object will be here, ascending. Then with the same height, it's going to start to descend again, which means that when t is equal to a, is also going to be when t is equal to a for this. They should give exactly the same height. So I am going to let 30 over 7 minus 9 over when t is equal to a plus 7, be equal to 12 minus 4a. Like what we have mentioned, there shouldn't be a difference in the height during the ascending and then descending. At the point when the ascending and descending, at the point where it experiences a stationary moment, okay, the height should be exactly the same. Okay, so regardless of whether you use this or this, it should give you the same height. So with this, let's try to solve for a. What can we do? So how about rewriting this as 4a minus 9 over a plus 7. This is equal to 54 over 7. Should we multiply throughout by a plus 7 and continue to solve this as a quadratic? Of course, we can do that, but if you look at the question didn't really ask you for the exact value for a, so why not let's just use our calculator, draw the graph on the left-hand side, draw the graph on the right-hand side, find the intersection to give you the value for a. So from our graphing calculator, we can actually solve for a. Okay, if you were to do that, a is going to be equal to 3 significant figures, 2.17. And the last part 5, we are supposed to sketch a graph of y is equal to ht from 0 to b. So in the beginning, it is going to be this. And in the beginning, it is following this, which is a rational expression. If I were to be sketching this, let me just do a super quick sketch, okay? This will have a horizontal asymptote of y is equal to 30 over 7. And you have a vertical asymptote of x is equal to minus 7. So we have something that is like this. X is equal to minus 7. If I were to sketch this into my calculator, I'll be getting something that is like this here. Okay, and the other portion is going to be this. This, then after that here. What is this number here? This is t, this is going to be y, and I'm sketching the graph of y is equal to 30 over 7 minus 9 over t plus 7. This is going to be equal to 3. The y-intercept is going to be equal to 3. We can definitely use our calculator, but at the same time, this is what the question has mentioned to us also. In the beginning, when t is equal to 0, the height is equal to 3. So this is equal to 3, a is equal to 2 point something. So from 0 to a, this is a, we will be getting this portion of the graph. Okay, so this is the portion I'm going to be transferring to my graph of y is equal to ht. Let me draw the graph. So let's say this is the y-axis. Let's say here we have the x-axis. So from 0 to a, let's say a is here. From 0 to a. From 0 to a, I'm going to be sketching this portion. So let's say the graph is like this. Okay, this is A. So here it's going to be, we are going to be sketching it by letting t be equal to 0 all the way until t is equal to b. So this is going to be a solid dot when t is equal to 0. This is t. And this is going to be at 3, right? I'm sketching the graph of y is equal to h t. And when it is at a, substituting a into here, this value here is going to be equal to 30 over 7 minus 9 over a plus 7. Okay, then after that, it's going to be experiencing this. It will continue from here. Then from here, it's going to go all the way until b. 12 minus 4b. And when will this be happening? B is going to be equal to 3, right? Okay, so a is going to be 2 point something, b is going to be equal to 3, so it's going to be somewhere here. So from here, it's going to go all the way down as a straight line to here, which is b. And because it can be equal to b, so this is going to be a solid dot. This will give us the graph of y is equal to ht. And this brings us to the end of the paper. I hope this is a good enough paper for us to be trying as a practice. Although it is not a very difficult paper, but I definitely feel that through doing a paper that is like this, we will be able to get to some of the core ideas and do a bit of practice at the same time. So I guess it is a good practice.